Alright, today we are learning to identify transformations as similarity or congruence transformations. Doesn't that sound like a lot of fun? Anyway, similarity transformations are transformations that result in an image that is the same shape as the original but a different size. Similarity is same shape, not necessarily the same size. Whereas a congruence transformation is a transformation that results in an image that is the same shape and the same size as the original, because congruent means same shape and size. So, we are going to identify the transformation from the original to the image and tell whether the two figures are similar or congruent. Okay, well, looking at those, you know they're not congruent because they're not the same size. Remember, the ones with the little commas, this is our image, and this little tiny is our original. Okay, so we're going to look at the original vertexes. A is at 1, -1. B is at 2, -1. C is at 2, -2, and D is at 1, -2. Okay? Now, we are going to look at the coordinates of the image. Okay? A falls at 3, -3. So A, that's a little, that comma, I keep saying comma, is actually prime, but I figure you'll know what comma is over prime every time, so I just say comma, is at 3, -3. Okay? B prime, or comma, is at 6, -3. C prime is at 6, -6. And D prime is at 3, -6. So, in order to get to your image from your original, we had to multiply our x coordinates by 3 and our y coordinates by 3. Okay? And you can see that because on A, 1 times 3 is 3, -1 times 3 is -3. And here we should get the same coordinates as we did in this list. B, 3 times 2 is 6. 3 times -1 is -3. C, 3 times 2 is 6. 3 times -2 is -6. And D, 3 times 1 is 3. And 3 times -2 is -6. Okay? So, the coordinates of ABCD, or of the image, are 3 times larger than the coordinates of ABCD. So the transformation is a dilation because it got bigger, so it's a dilation, with a scale factor of 3, and that number has to be greater than 1 because we enlarged it. So the two figures are similar, but not congruent. Identify each transformation from the original to the image and tell whether the two figures are similar or congruent. Now A, it's kind of, difficult to tell. We can't just assume, though, that they are congruent just because they look congruent, because there might be a little tiny bit off, which would make them similar. So the original trapezoid ABCD and the image trapezoid ABCD, and if you can tell, this is rotated, right? So, it's rotated 90 degrees because it goes and it's clockwise because it goes clockwise. All right. So, and it's just in the next quadrant over, so we know it's 90 degrees. So the original of A, the original coordinates of A is -2, 5. B is 1, 4. C is 1, 1. And D is -2, -1. Okay? Just went and got all my coordinates. That's all I did from my original, so not with the little comma. My image of those, because it's a rotation, my rule is that I multiply x by -1, and then I flip the coordinates. Okay? So, -2 times -1 is 2, and then I flip them so I get 5, 2. So then I have 1 times -1, which is -1, and then I flip, so I have 4, -1. Then I have 1 times -1, which is -1, and I flip, so I have 1, -1. And then I have -2 times -1, which is 2, and then I flip, so I have -1, 2. Okay? So, the image is a 90 degrees clockwise rotation, because if we were to go look at these 4 points, we would find that A is in fact at 5, 2, B is in fact at 4, -1, C is in fact at 1, -1, and D is in fact at -1, 2. So because those are all in the image at the exact coordinate point that we said they're supposed to be at, they are congruent. Okay? So, for B is a translation because it only moves up and down and left to right. In this case, it only moves up because our image is below, or our original is below our image. Okay? So, we go to our original. We see that A is at -1, 3. B is at -2, 1. And actually, this is the -3 up here on A. And C is at 3, -1. Okay? Now, what I'm going to do is I'm going to look and see, well, for my B, I had to go up 1, 2, 3, 4 points. So I had to go up 4. So I'm going to add 4 to each of my Y coordinates because it's along the Y-axis. Up means Y. So my rule for this is my X doesn't change because I didn't go left or right, and then my Y I have to add 4 to. Okay? So that's going to be my rule for my image. So my X stays the same. -3 plus 4 is 1. B, my X stays the same at -2, and 1 plus 4 is 5. C, my 3 stays the same, or my X stays the same at 3, and -1 plus 4 is 3. Okay? Now I'm going to go check and see if these 3 points are in fact the 3 coordinates of where our image falls. A is at -1, 1. That checks out. B is at -2, 5. That checks out. That's supposed to be a check mark. And C is at 3, 3. And that checks out. So yes, these are congruent. Okay? So, let's first go up here and write our rule for our rotation. Our rotation is -1 times X, which then leads us to Y -X. Okay? Or actually, take off that negative sign. That might confuse the heck out of you. What we do is we multiply our -1 times X, and then we just flip and put our Y first and our X second. Okay. On this one, we have a reflection. Okay? So, what we're going to do here with our reflection across the x-axis is we're going to multiply our y by -1. So we're just going to have x and then -1 times y. That is going to be our coordinate for our image. So first we're going to look at our original. A is at -1, 2. B is at 1, -3. C is at 2, 2. Okay? So our x's all stay the same for our image, and our y's are multiplied by a -1. So -1 stays. 2 times -1 is -2. Okay? For B, our 1 stays. Our -3 times -1 is 3. For C, our x stays at 2, and 2 times -1 is -2. So now we got to go check and make sure that on our reflection they have these coordinates. Man, that looks like a face. Anyways, so A prime or A comma checks out at 1, -2. B prime or B comma checks out at 1, 3. And C prime or C comma checks out at 2, -2. So they are congruent. Okay. That was a long example because there were 3. So, now you have your check it out. Identify each transformation from the original to the image and tell whether the two figures are similar or congruent. So you need to get a piece of graph paper, and you first need to graph A and then graph B on the same graph. And then you need to tell whether they're similar or congruent. If it's rotated, you need to follow the rule. If it's reflected, you need to follow that rule. And if it's translated, you need to follow that rule. Okay? Once you've followed the rule and got your new coordinates, you need to make sure that your image is in fact at those coordinates to see whether they are similar or congruent. If they are exactly, they're congruent. If they're not, they would be similar or you did something wrong. I mean, could be either or. Try on those. If you need help, come ask for help. And we will probably be spending a little bit more time on this together because these are not necessarily easy unless you understand the rule and the rule that goes with each one. So if you have the rule down, they're pretty, easy to follow. But it's getting those rules down that is difficult.